welcome to CEC lectures. Myself Dr. Priti. I am from Department of Computer Science, Aribhat College, University of Delhi. So in this series of computer networks, initially if you can recall, we started with ISO OSI model, and we have looked into the 7 layers or the whole structure of that model in brief. And then gradually we started exploring each and every layer out of those 7 layers, and we did that with the physical layer, and now we are working on data link layer. So within this kind of topic of data link layer, presently we are going through the protocols which are used on that in this data link layer, and the topic which we are covering is sliding window protocol. So in my previous lectures, we have looked into 2 different protocols. One is stop and wait protocol, another one is go back and protocol, and today's agenda is selective repeat ARQ. ARQ is automatic repeat request. Basically if we try to recap the previous 2, so in a stop and wait, your sender is going to send one frame, and then it will wait for the acknowledgement from the receiver, and it is not going to send the next frame unless the acknowledgement of the previous one is received. So it is kind of stop and then kind of wait for the acknowledgements, and hence the name stop and wait protocol. Moving further, we looked into go back N protocol, which is in short it is known as GBN. So in go back N, the frames are sequentially numbered and a finite number of frames are sent. If the acknowledgement of the frame is not received within the time period, so there is a timer for the receiving the acknowledgement of each and every frame. So if the acknowledgement of a particular frame is not received within a particular time period, all the frames starting from that frame are retransmitted. So that basically means that you are for example, you are transmitting 5 frames sequence numbered as 0 to 4, and then let us say you have not received the acknowledgement for the frame number 3, then 3rd and 4th both are needed to be retransmitted, and here is a figure which is kind of describing this. So here in this you can see there is a sender window, another side you have a receiver window, and hence these are known as sliding window protocols. So there is a frame 0 which is being received at the receiving end, then there is frame 1, but the acknowledgement of frame 1 is received, while frame 2 when being kind of sent is lost on the way, and hence obviously there is no acknowledgement corresponding to this frame 2, or we can say there is NAK. NAK is negative acknowledgement. So all the frames starting from frame 2 in this particular example, both the frames frame 2 and frame 3 are to be retransmitted, and we have seen this protocol in detail. So this was your go back N protocol. Now we are going to move forward to selective repeat protocol, which is in short we can say SRP. Basically it is used in all the data transmission methods which are kind of the reliable type, and hence it is going to kind of improve upon the protocols like GBN, which is go back N. The idea or the strategy here is that only retransmission of packets is going to happen only for the packets which are lost or corrupted. In go back N, it was one particular packet or the acknowledgement is missing, and then all other following that are to be kind of retransmitted within a particular window. But here the retransmission is only going to be happen for the lost or corrupted ones. So unlike go back N, which retransmit all the packets from the point of failure, your selective repeat protocol is more efficient obviously, particularly for the unreliable links, because it is going to minimize the number of retransmission. So if your link is unreliable, it will ask for kind of too many retransmission if you are going to use your go back N protocol, but your SRP, which is selective repeat, is going to minimize the number of retransmission, because it will ask for retransmission of only that particular frame for which the acknowledgement is missing. Also, the important characteristics here is it requires a full duplex lens, a full duplex link, allowing both these sides to be kind of, we can say, communicated at a particular point of time simultaneously, allowing data to be sent in both the directions simultaneously, that we can say, because one side it is kind of the packets are going, and on the another side acknowledgement is being received. Now, looking into what are the key characteristics of this particular selective repeat protocol, one is window size. So, please recall in the stop and wait protocol, the window size for both the senders end as well as the receivers end was only one, because one particular packet was sent and the acknowledgement is being expected. Now, here as far as window size, both the sender's window size, which is denoted by WS, and the receiver's window which is denoted by WR, are of equal size, and that even does not happen in the previous one, which is go back N. Moving on to the next key characteristics. So, the first one is the size of the window, both the sides is equal. Moving on to the next key characteristics, which is about packet handling. So, receiver can accept and buffer the packets that arrive out of order. This allows it to hold on to correct packets while waiting for a retransmission of a lost one. So, for example, there are kind of 5 packets starting from 0 to 4, and let us say the second one or the number 2 is missing, while 3 and 4 are being kind of received. Then your receiver end is going to buffer those packets even if they are arriving out of order. So, that means they are going to hold on to these packets while waiting for the retransmission of the second one, because only the second one will be retransmitted if second one is being lost, not the third and fourth as it was in go back N. Then retransmission is the third characteristics. If we talk about your selective repeat, the sender only retransmit specific packets that were not acknowledged after a timeout or upon receiving a negative acknowledgement. So, either it is kind of no acknowledgement on a timeout, or it is kind of a negative acknowledgement. Both these situations are being handled using the retransmission of that particular particular packet. Efficiency, if we talk about the efficiency of selective repeat protocol, that is going to be given by the formula, which is n divided by 1 plus 2a. If we talk about the terms here or the variables here, n is the window size and a is the ratio of the propagation delay to transmission delay. So, a here is T of p divided by T of t. So, that ratio. So, the formula for the efficiency of selective repeat protocol is n divided by 1 plus 2a, and if you can recall this was also for go back n. And this protocol is also a kind of sliding window protocol. You must have got this by the explanation which I have given. It is also used for error detection and control in data link layer. So, in selective repeat protocol, if we look into kind of detail, we know that the sender sends the several frames specified by a window size even without the need to wait for the individual acknowledgement from the receiver. And this was also a kind of, we can say, bottom line, or this was also a point in go back n ARQ, automatic repeat request, while this was kind of absent in stop and wait protocol, because in stop and wait it was kind of send the packet and then wait for the stop and then wait for the acknowledgement. In selective repeat protocol, the retransmitted frame is received out of sequence. So, that means sequence control is also happening at the end of we can say receiver, while this was not the characteristics in our previous protocol. So, in selective repeat ARQ protocol, only the lost or the error frames are retransmitted, whereas the correct ones are received and buffered while the receiver is going to get the retransmission for the lost ones. So, that means receiver has to keep the track of sequence number, buffer the frames in the memory and sends the negative acknowledgement for only the frames which are missing or damaged. The sender in turn will send or retransmit a packet for which the negative acknowledgement is received. So, in order to understand this whole phenomena, let us look onto a figure which is available on the screen. So, here we have a sender side and a receiver side, and we are going to kind of send the 5 packets which are numbered from 0 to 4. So, let us say from sender side the packet number 0 has started, and then it is received on the receiver side, and the moment it is going to be kind of sent, timer is going to be kind of started for the packet number 0, so that within the stipulated time, whether we are going to receive the acknowledgement at the sender's end or not, that kind of that thing can be tracked. Then if we are going to go with the second frame obviously without waiting for the acknowledgement of frame 0. So, we are going to set the timer for 1 and the frame 1 has been sent. Meanwhile, the ACK 0, which is the acknowledgement for the frame 0, has been received at the sender's end, and similarly acknowledgement 1 has also been kind of received at the sender's end. Meanwhile, frame 2 has started from the sender's end to the receiver's to the destination, we can say, but this acknowledgement corresponding to frame 2 as you can see by a red cross in the figure is kind of we can say lost somewhere in between, and then that acknowledgement 2 is not being received at the sender's side. And then obviously a timer was started when the when the frame number 2 has started from the sender's side, and this when acknowledgement is not being received at the sender, timeout is going to happen, and in case of timeout your sender is going to repeat the only the particular frame which is frame number 2. Meanwhile, your 3 and 4 has also kind of reached over there, and the acknowledgement corresponding to the frame 3 has also been received, as you can see in the figure. So, only the mismatched one or only the missing one, which is 2 here, is going to be kind of we can say retransmitted, not the all ones. So, yes, we can say stop and onto stop and wait we have a modified and an updated version of the protocol which was go back n, and as compared to go back n, our selective repeat is also kind of an kind of we can say improved or an updated version. Now, here as we have seen that in step 1 the frame 0 sends from sender to the receiver and timer is being set. At step 2, without waiting for the acknowledgement from the receiver, another frame which is frame 1 is sent by the sender by setting the timer for it. This is what I am going to re-describe this figure again with the help of steps. So, in step number 3, if you can see what is happening, frame 2 is also sent by the receiver by setting the timer, and here also it has not waited for the previous acknowledgements of frame 0 and frame 1. Moving forward, the sender is going to receive the acknowledgement 0, which is ACK 0 from the receiver, signaling that the frame 0 has kind of received successfully. And this has happened within the timer of the frame 0. So, then that timer is closed and the next frame, which is frame 3, is being sent in the next step. So, whenever the sender receives the ACK1 from the receiver, signaling that the frame 1 has been kind of received within the frame 1 timer, again that timer is also closed and the next frame, which is sent frame number 4, is being sent. So, how many frames can be sent at a particular time? That is being decided by what is the size, what is the window size of the sender and the receiver. And I have told you in the key characteristics that in selective repeat, both sender and receiver are having kind of similar same size of the window. Moving on to the next step in that figure, if the sender is not going to receive ACK2, which it did not receive from the receiver within the time slot, it declares timeout from the frame 2 and it resends the frame 2 again, because it thought that the frame 2 may be lost or damaged. So, there can be again two cases: either the frame 2 has been not not received at the receiver's end, so obviously no acknowledgement is being sent by the receiver, or even the acknowledgement is being sent by the receiver, but the acknowledgement itself is kind of, we can say, missing here. So, both the cases can be there. But if we talk about selective repeat particularly, it is used in reliable in order delivery of the in order delivery of the data packets, and this selective repeat ARQ is also used for noisy channels, or we can say noisy links. It also manages the flow and the error control between the sender and the receiver. Only data frames are resent which are damaged or lost. So, both the cases again, so any frame is lost or damaged, then the receiver sends a negative acknowledgement to the sender. If the and if the frame is correctly received, it sends back an acknowledgement. So, there can be two cases: either it is in ACK, which is an acknowledgement, or it could be an negative acknowledgement, which is denoted by NACK. So, negative acknowledgement or acknowledgement depending upon what is the situation at the receiver's end, and hence accordingly your sender is going to kind of take the action of sending, or we can say resending, the damaged frames, only the selected damaged frames, and hence the technique is named as selective repeat. And this ACK and NACK, which is in acknowledgement and negative acknowledgement, also have the sequence number of the frames that helps the sender to identify the lost frame. And this is all is kind of, we can say, time dependent. The sender sets a time for each frame. So, whenever the timer is over, sender has not received any acknowledgement for the frame, then the sender knows that a particular frame is either lost or damaged. Both the cases can be there. So, the sender backs the lost or the damaged frame once the timer is out. So, it is going to wait for till the point your timer is on. So, both the senders and the receivers will have window of the same size. The window on the sender side cover the sequence of the data packet that are sent, that are already sent, or that are kind of still to be sent. On the other end, if we look into the window on the receiver's side, it is going to cover the sequence of the data packets that are received, or they are still kind of going to be received. Then what is going to be the size of the sender's window and the size of the receiver's window, because they both are kind of we can say equal here in this protocol. So, sender's window size, please recall that it is represented using WS, and the receiver's window size is represented by using WR, where S and R are kind of written in subscript. So, coming to the size of the sender's window, that is going to be 2 to the power m minus 1, where m is the number of bits used in the header of the packet to express the packet's sequence number. So, whatever the sequence number of the packet is there, in order to represent that packet number, whatever number of bits are going to be used, if we name those bits using m. So, 2 to the power m of minus 1 is going to be the size of the sender's window, and hence the window size of the receiver is also, as I have already told you, that it is same as that of the sender. This is also going to be 2 to the power m minus 1. Now, till this point we have seen one utopia protocol, which was kind of an hypothetical one, then one very restrictive protocol which was stop and wait, and then we moved on to kind of, we can say, two kind of slightly efficient protocols, which are go back N and selective repeat. So, which one is to be used when? So, if there are kind of low errors, we should go with, or we might use go back N. If errors are high, then we might use selective repeat, because in in low errors it is kind of your go back N is asking for much much more retransmission than your selective repeat is asking for. So, in case of high errors, we can use selective repeat. So, if in case of high errors we are going to use go back N, this will involve a hell lot of retransmission. But if we talk about low errors, we might use go back N. Also, another factor which is important in deciding which one is to be used, either GBN or SR, is the bandwidth. If the bandwidth is cheap, we can use GBN, because it is not going to affect much that kind of how much retransmission, if retransmission we are doing, only if bandwidth is considered. Obviously, retransmission is kind of an kind of a damage in the sense, I can say loss or a work or a piece of work to do. But if bandwidth is cheap, and looking only onto the bandwidth, we can use we can say that we can use GBN. If the bandwidth is costly, we might use selective repeat. So, that is that actually depends upon how your network situation is. And now, if we talk about if we want to kind of summarize this go back and selective repeat in terms of specifically the differences between the two, we have seen the important one is in go back N, all the subsequent frames must be sent again if a particular frame is corrupted or lost, and in selective repeat only the frame that has been corrupted or lost will be sent again. Now, your go back N wastes a lot of bandwidth if the error rate is high, and in case of selective repeat the bandwidth loss is less. Then your go back N is less complicated, while your selective repeat is difficult to manage, because sorting and searching is required, and also it requires more storage in order to keep the buffer of all those frames which are not received in order, but they are to be stored in case of selective repeat. In case of go back N, sorting is not required, while in case of selective repeat, sorting is obviously done in order to ensure that the frames are in correct order, or we can say in order to identify which particular frame is missing. So, sorting is definitely required. Similarly, if we talk about the searching thing, searching is not required in case of go back N, while search is required in your selective repeat in order to look for which one is missing. Then your go back N is used more frequently because of being complicated. The selective repeat, we can say it is used less frequently. So, in this lecture, what we have looked into is we have seen the selective repeat protocol. We tried to understand all the nuances and the key characteristics of it, and we have also seen the differences between the two, which is go back N and your selective repeat and which one can be used in which type of applications or in which type of scenarios. Here is a list of references which is being used for the preparation of lecture. I will see you in the next. Till then, take care. Goodbye.